Hello, and welcome to the ALCTS webinar on ArtFrame, Extending Library Ontologies for Works of Art. I am Amanda Stone, a member of the ALCTS Continuing Education Committee, and I will be your host for today's webinar. Our presenters today are Melanie Wacker of Columbia University and Amber Billey of Bard College. Melanie is the Metadata Coordinator at Columbia University Libraries. She works across the organization to ensure the integration of digital metadata with local and national systems. Amber Billey was the metadata librarian at Columbia University Libraries. Since November 2017, Amber is now the systems and metadata librarian at Bard College. She continues to work with Melanie on the LD4P project and the ArtFrame linked data ontology extension for art objects. Both bring much expertise to today's topic, and we are fortunate to have them with us today. A few logistics for today's presentation. All attendees are muted to prevent background noise, and we do not have interactive chat capabilities. You may, however, comment on today's presentation using Twitter. The hashtag is ALCTSCE. We do not monitor the Twitter feed, so if you have questions, please type them into the question box on your screen. We will have time for Q&A after the presentation. This webinar is being recorded, and you'll receive an email with links to the recording and presentation slides shortly after the presentation concludes. And now, here is Melanie. There will be a slight delay as we change presenters.
Hello, welcome everyone. Thank you for joining us today to hear about the ArtFrame project, a 2-year exploration to extend and enrich the BIBFRAME ontology for the cataloging of the many works of art that libraries own and catalog. This is us, Amber Billey from Bard College, and myself, Melanie Wacker from Columbia University. However, we are only the presenters for today's webinar and are representing a large group of amazing contributors to this project. We will introduce the ArtFrame team and other collaborators later on in this presentation. We have a full agenda for today. These are the topics we are planning to cover: the larger LD4P project, an overview of our domain-specific sub-project, a review of the existing cataloging standards for art, our use cases, the steps that we went through to model these use cases and develop our ontology extension, tools, and last but not least, what we are taking away from all of this. If you watched the previous webinars in this series, then you are already familiar with LD4P, Linked Data for Production, a 2-year Mellon-funded collaborative project. These are the 6 partners: Columbia, Cornell, Harvard, Princeton, Stanford, and the Library of Congress. Some of the overarching issues regarding linked data work in libraries were explored together, but each institution also committed to mostly domain-specific sub-projects requiring us to develop extensions to BIBFRAME, the core ontology. You'll see those areas listed here on this slide. Several of them are part of this ALCTS webinar series. Today, we will focus on the work of the ArtFrame group. Why did we choose art as our test domain? Over the years, the museum and library communities have developed separate descriptive cataloging practices, even though many museums hold library objects and many libraries contain museums objects. Libraries have frequently used the ILS system and the Mark 21 AACR2 and RDA cataloging traditions to describe these art objects along with the traditional library materials. Now the library community is moving beyond the MARC record into the realm of linked open data. The Library of Congress initiated the Bibliographic Framework Initiative, BIBFRAME, in 2012, and the first version of the BIBFRAME model and vocabulary was made available for testing. Initially, much of the focus had been on traditional library formats, even though the paper, Bibliographic Framework of a Web of Data, released in November 2012 by the Library of Congress, stated that, and I quote, The goal of the Bibliographic Framework Initiative is to develop a model to which various content models can be mapped. This recognizes that different communities may have different views of their resources and thus different needs for resource description. This is especially pronounced as one leaves the book text media and considers images, still and moving, cartographic resources, archival collections, and ultimately cultural artifact and museum collections. Columbia was first approached to be part of the LD4P project in late 2014. All institutions that decided to participate were starting to scope their particular sub-project. It just so happened that our art properties curator, Roberto Ferrari, and I had worked in a local schema to describe Columbia's art collection that was based deeply in existing museum practices, but since we were unsure at the time where the data would eventually reside, we had also made sure that the data would be easily portable, meaning we wanted to be able to easily map it to whatever schema or system we wanted to make it available in. We also wanted to ensure the interoperability with other collections, library and archival within our system. Therefore, the data uses value vocabularies that are all available as linked open data, such as the LCPCC name authority file, TGN or AAT, and is largely already reconciled, meaning it already includes URIs within the data. Columbia University actually owns quite a sizable art collection. Art Properties is a special collection within Columbia Libraries. 95% of the collection has been received as gift or bequest since there is no actual acquisition budget. The collection's primary use is to support curricular integration, educational programs, and research and study. As an extension to the educational mission, works are regularly loaned to exhibitions worldwide and displayed in selected areas on campus. Many more are held in storage. The art collection reflects all cultures and time periods and ranges from paintings and works on paper to outdoor sculpture, decorative arts, and everything in between. This variety and the availability of a clean set of metadata made it the perfect test collection for us. The collection descriptions are currently maintained in spreadsheet format, but the available metadata has been mapped into MARC records and is being transformed to a batch process. The process gets repeated from time to time as more and updated descriptions become available. More than 3,600 descriptions are now available through Clio, Columbia's library catalog. This is one of our art properties MARC records. So how would such a MARC record that is clearly not describing a traditional library resource translate into BIBFRAME? Much of 2015 was spent as an initial period of investigation. For example, we looked at available tools and touched base with other linked data projects in the art domain. We also mapped the art properties data to BIBFRAME 1.0 to document where it worked well and where it didn't. This grant period began in March 2016 and was slated to go through March 2018. And this is a timeline that was initially developed in the early planning phase. BIBFRAME 2.0 had just been released, so we had to repeat some of the prior evaluation work that was based on an earlier version. Generally speaking, we were just a little bit too optimistic. You can see, for example, that we had only 3 months allocated for ontology development and data modeling. We still get a good laugh out of that when we look back at it. We accomplished a lot, but we also learned a lot. For example, developing an ontology takes a lot longer than you would expect, even if it's quote-unquote just an extension to an existing one. There are also a lot of interdependencies with other parts of the project, for example, tool availability. Staffing changes can slow the work down considerably. Key staff can get pulled off to work on other priorities. Luckily, our project end date was extended to June 2018. We wrapped up the ontology modeling and OWL file creation and are now working on an application profile. Many people have contributed to this project. On the Columbia side, the team is comprised of staff from Columbia University Library's Original and Special Materials Cataloging Division and the Avery Art and Architecture Library, including our art properties curator. While the time prior to the official start of this grant period was spent focusing on our own local data, a big part of the LD4P project aims to get the community of practitioners involved and to mobilize our communities. For ArtFrame, we were so lucky that so many of our colleagues agreed and contributed so much. The so-called Extension Group consists of the Library of Congress Prints and Photographs Division, the Clark Art Institute, the Morgan Library and Museum, and the Cataloging Advisory Committee of RSNA. I am now about to hand over to Amber Billey. You may have noticed that she's mentioned both as part of the Columbia team and the Extension Group. That's because she moved from Columbia to Bard College last year, but luckily remained on the project. Amber will now take over and walk you through the steps we took to develop the BIBFRAME ontology extension.
Thank you, Melanie, for that fantastic introduction and the overview of the project. So how do you create an extension for an ontology like BIBFRAME? Over the next 20 or so minutes, I'm going to take you through our process while introducing ArtFrame, the linked data ontology extension to BIBFRAME for describing works of art. Melanie already covered the first two important steps. First, identify an issue or domain that needs the ontology. Libraries have a lot of art, so let's create an ontology extension for it. And then gather a community of domain experts. We were so lucky to have such wonderful colleagues that joined us on this project. The next step is to survey the existing landscape. For this part of the process, we conducted a literature review and analyzed existing methods for describing and cataloging art. The scope of the literature specifically focused on articles and works about descriptive cataloging of art objects in libraries. A review of the literature revealed several broad themes. The uniqueness of art objects, that these are challenging and difficult things often to catalog. But with that challenge, there's an advantage to describing art objects using existing library cataloging standards. Sometimes we need to create new cataloging standards to describe artworks. And then there's also potential usefulness in using linked data for art objects. Let's review some of these existing practices for cataloging art. We, of course, have our MARC-based cataloging practices that are leveraged to describe and make accessible art objects in libraries through the library catalog. Our general content standards, such as AACR2 and RDA, include sections or aspects for describing visual resources, three-dimensional objects, or realia. Some new domain-specific content standards have been developed to specifically address cultural heritage materials. For example, this wonderful ArtMark sourcebook that I found, or more specifically, our recommendations from RLIS North America and the DC RMG or CCO. And then, of course, we have best practice guides and local practice, and that's this ArtMark guide, is some of those best practices developed by domains. And RLIS develops their best practices as well, and of course, our local practices. There are several schema and ontologies to analyze for potential modeling and reuse for non-MARC metadata for art. There's Dublin Core and VRA Core, of course, CDWA and CDWA Lite. And as far as linked data ontologies, we can reuse ontologies from DC terms, possibly VRA Core, Lido, CDOC CRM, the Linked Art Project ontologies. But what about BIBFRAME? We were focused primarily on BIBFRAME with this grant. So how would we go about extending BIBFRAME for art? After you've surveyed the landscape, the next step is to identify use cases. But how do you develop use cases? You reach out to domain experts. In our case, we had the participants in the group. We also looked at our public services librarians at the Avery Library at Columbia University Libraries, and even our end users about how they search for art and art-related information. We then drafted a list of use cases that included the title or the goal of the use case, the mode of use for that use case, primary stakeholders involved, the scope, the priority of that use case, whether it was high or low or sort of intermediate, and then a story. So the story might be something like, I'm a blank and I'm trying to do blank so that I can accomplish blank. And then of course we have examples and notes. Here's an example of one of our use cases. In particular, history of custodianship. We're going to follow this use case into its fruition as an actual ontology throughout the rest of my section of this presentation. We developed 52 use cases. That's a lot of use cases. But it was fantastic to see the different ways that our users and our public services librarians and our domain experts felt that we needed to, how we needed to describe art objects to meet these use cases. So here's a sampling of the use cases developed by the group. We have discover works by an artist, along with other library resources about that artist, such as catalogs, archival collections, auction catalogs, artist files, or bibliographies. Discover related works held by the same institution. Search and sort by genre. Search and sort by artwork size. Find artworks that are heavily damaged. Identify artworks associated with alumni donors from a particular school or college or division or department. Find images of an artwork. Find artworks to illustrate the cultural context of a specific place. Track information about labels and marks on frames or other supports. Find artworks by variant titles. Identify long-term loans. Artworks associated with an event. So for example, here we had find all artworks that were produced as a wedding gift for a given period. So you can see we had wide-ranging use cases, and these are just a sampling of the 52 use cases. After you've thoroughly determined as many use cases as your domain experts and end users can possibly think of, you might need to organize those use cases into thematic groups to make them more organized and manageable. For ArtFrame, we took our 52 use cases and distilled them into 12 groups. Those groups are names and agents, related works, genre, facets, types, work types, classification and styles, physical characteristics and properties, conditions or alterations, object history, related images, subject or aboutness, annotations, titles, administrative metadata, and related events. After the use case development, you move on to the entity modeling phase. With entity modeling, you analyze the various key properties of a use case and extract the possible entities. These are the subjects, predicates, and objects in those use cases. These entities then just might become the new classes and properties in your ontology. So here we see the history of custodianship use case broken down into its various entities. If you look at the second row in this screen capture, number 6.0, history of custodianship, we can see 3 entities identified. The first being agent, so the person or organization that was the custodian of a work. And then entity 2 would be its relationship. So here we thought about reusing the MARC relator code, so the MARC relator code for own as an ownership. And we might also want the date. So here we may be thinking about reusing the BIBFRAME date property. And then of course we have the work itself in the third entity. So once you start to break this down, we can start seeing those relationships of an agent owns a work in a given period of time. So I like to think that ontology development is better with friends. And in this case, we were so happy to be able to join with our colleagues with the Rare Materials Group based out of Cornell. And I say happenstance leads to collaboration because it was really, I happened to be on a phone call on the Rare Materials Group, and I noticed that their use cases were very, very similar to ours. And if you think about it, rare materials and art objects, these are unique objects in library collections. And of course, we have many overlapping use cases. So we were able to pair up with them and really develop some common ontologies that we think will be useful for describing rare objects and art objects in general. So with that, we continued our work on ontology development together. We had 2 in-person meetings. This is the first in-person meeting that we had in 2017. Look at all those beautiful smiling faces. And we worked together through some really complicated, sticky ontological modeling issues. And it was really fantastic to be in person and to work through those issues together. So the next step in our process is to actually do that ontological modeling. So what does that exactly mean? Well, we found out that it is best to do this work in person, in small groups. It's really hard to do this over once a week, 1-hour phone calls via, GoToMeeting or WebEx or whatever virtual software, meeting software you have. It really was just best to lock ourselves in a room and start thinking and drawing and talking. So here you can see we're actually working on the custodial history model. There's Rebecca Yunus from Cornell University Library, and she's using that dry erase eraser because a lot of modeling is just looking and drawing arrows and thinking carefully about how this data should be formulated and how we want to describe these relationships between the various classes and properties. For this work, whiteboards are wonderful. When you have a draft of the model complete, it can be very useful to visualize the model using diagramming software. We commonly used Google Drawing as an application out of the Google Apps utility, and that was really useful. And you could also use other diagramming software. Draw.io is also very good, but this makes it very easily shareable for collaboration and feedback. This is a visualization of the custodial history model, and that became the foundation for the ontology model recommendation documentation. So there are several steps in developing an ontology recommendation. Based on that model, we can formulate the classes and properties from the nodes and relationships in the model. We then list the necessary classes and properties that are in the model. We determine if any vocabulary reuse is possible. This is key when extending any core ontology or using best practices of reusing existing ontologies. You define, for any of those new classes or properties, you will define them as necessary. So creating a label for them, defining a URI, having a formal definition or scope note, domain, and defining those domains and ranges for that new class and property. Then you determine and define any necessary named individuals, or AKA controlled vocabularies, to support the model. And this is something that we're very familiar with our work, that you might have an element in your schema or in your, a place in your MARC record where you need to have a controlled vocabulary. And so just like in linked data, we have these named individuals or controlled vocabularies that would be utilized to populate a specific property. So here's the custodial history model. Here are most of the classes, subclasses, and properties for the custodial history model. I say most because not all of the activity subclasses fit in this slide. There are a lot of ways an agent can interact with an object in a custodial history of an object. So I'll give you a moment to take that all in. So let's take a closer look at this custodial history model. This is very important information for art and other cultural heritage objects. CCO has specific instructions on recording ownership history, as does RDA. And we can record this information in a MARC 561 field. And here's an example of how we could do that. Here's this MARC 651. It says, originally collected by Paul Jones and maintained by his nephew, John Smith, after Jones' death. Purchased in 1878 by Henry Green, who added prints and drawings purchased at auctions in New York and Paris throughout 1878 through 1893. Whew, there's a lot of rich information in that note. If we break it down, the entities involved in that 561, we can see all the potential relationships that that ownership history, and that's in that squared off box there that I have on the right. Those are all sort of like all the entity modeling that you could maybe draw out of this 561 field. Unfortunately, BIBFRAME doesn't do much better than MARC. The ownership history is recorded using simply just a BF custodial history predicate. And again, it's simply a text string. With ArtFrame, we wanted to be able to discretely trace the chronological history of an object. What happened to it, when, where, and by whom. If we take this example from the 561 field and map it to the ArtFrame model, we get this. Whew. All right, let's break it down. The item in bold is the artwork in hand that we're cataloging. With the ArtFrame model, we can discretely describe the 4 custodial events that occurred in its history. We can see that it was first owned by Paul Jones, and if we had a URI for Mr. Jones, we could use that instead of the text string. For simplicity, though, I just kept it as Paul Jones. It was then inherited by John Smith and then bought at auction by Mr. Green in 1878, who owned it with other items. This is items 2, 3, and 4 in this example, which those items were also bought at auction in New York and Paris. And we also could have used the URIs for those locations too, but you know, here I just kept it simple. And he did this between 1878 and 1893. Whew. Well, it looks really complicated, but when you break it down, you can see how the pattern emerges. And it shows an elegant way to record this most important information about art objects. But how would this look if you actually encoded this in RDF? It looks like this. I won't go through this in detail right now, but I will point out the first 2 sections in the second column both share activity 4, which relates back to events with items 1, 2, 3, and 4. Activity 4 is an owner activity by agent 3, who is Henry Green. And we can see that we're bringing all the common shared custodial history under Henry Green for items 1, 2, 3, and 4. Let's explore another modeling example. This is use case 3.3, finding artworks that can be characterized by a certain style. Artistic style is very important to art objects, and it's often difficult to record in a MARC record. And before I go through this, I just want to say a very special thank you to one of our group members, Marie-Chantal Lecuyer-Coelho at the Bibliotek-o Nationale du Québec for these slides. That's why they look so different, but thank you, Marie-Chantal. So here we can see how content and data structures used in describing art objects, including VRA Core, CCO, CDWA, CDOC-CRM, and Lido, they have provisions for allowing catalogers to qualify an art object by its artistic style. On contrary, neither RDA or DCRMG offer guidance on how to record style or artistic period information. Likewise, there's no defined field in a MARC record for this information. And since BIBFRAME is directly derived from the MARC record, it provides no class or property for recording style information as a separate data element. On screen, you can see one of the strategies currently used by art catalogers to provide this information in the MARC bibliographic record. The style of this 19th century intaglio print owned by B&Q has been provided as a content note field along with the description of the scene depicted. Now you can see how the content note is translated into BIBFRAME. As you notice, the adjective phrase early romance or early romantic is still part of the larger text string. It itself is loosely qualified as summary. Alternatively, one could opt for a BIBFRAME note, but the result is still the same. The data remains unstructured and unidentified. As a solution seems unsatisfactory, the ArtFrame team evaluated this to see if we could reuse a property from another ontology. So initially, we thought about borrowing from VRA their style and period object property, but realized that it might be, in fact, too restrictive for it has the domain of schema creative work and a range of VRA style period. which is what you're seeing on the screen right now. But since we are developing our ontology as an extension of BIBFRAME, and that concepts of work in BIBFRAME and in schema.org are not entirely extensive, we might fall into some entailment issues. So we finally thought it might be safer to, at least for the time being, coin our own property has style period, as well as the inverse property is style period of, and leaving their respective domain and range open, that it might be used in a combination with various kinds of resources, including BIBFRAME works. Moreover, leaving the domain and range unspecified will allow data publishers to use both properties and controlled vocabularies of their choice. So for example, AAT or any other controlled vocabulary, without creating any of those undesirable entailments. So the ArtFrame and Rare Materials group created 19 ontology recommendation documents. Of course, we don't have time to go through them all today, but here's a slide that links our recommendations to the 12 use case groups. So for names and agents, we had attributions as the ontology model, related works, custodial history, exhibitions, awards, titles. For genres, we worked on the style period. For physical characteristics, we designed a measurements model and a materials model. For conditions and alterations, we have the physical conditions and markings models. For object history, we have custodial history, exhibitions, awards, titles. For subject and aboutness, we have style period, annotations, we have notes. We have a notes recommendation ontology model. For titles, we have, of course, our title document, our recommendation document, and for related events, we have an exhibitions model. For this project, we focused on modeling descriptions for works of art, and we'll address their related images and administrative data at a later time for future work. Once you have the modeling complete, you have to write it up and publish the recommendation so that the wider community can easily access the model and the recommendation. So we have to publish this model. And how do we publish it? Well, at first we used Google Docs. But this was difficult to share, and I don't know about you, but if I've got too many Google Docs shared with me, I get lost in my Google Docs. So we moved to GitHub and changed all of our documents to Markdown files or .md files. We like GitHub because it's an open platform, it easily integrates with existing tools and workflows, it tracks the history of any files, it tracks changes to files, and there's a public way to issue reporting or to submit issue requests. And while you have to have a GitHub account, that didn't seem too much of a barrier for our participants in the group. Once your model is published, you want to invite feedback from the wider domain community and from other domain experts. This might result in some changes and updating the recommendation document, but it's only going to make it better. After you've received that feedback, you can finalize a version of the model. Here is the finalized version of our custodial history model. You can view it on our GitHub repository, and I provide the link for you here in the slides. Once you have a stable version of your model, you can now encode the recommended classes and properties in a knowledge representation language to make it understandable and to be able to be processed by machines. For this work, we chose a language called OWL. What is OWL? Well, it stands for Web Ontology Language. They did a cute little flip with the acronym there so that we can actually just say OWL. And it has a an OWL is a semantic web language used to encode things or groups of things. These would be the classes and the relationships between the things. Those would be the properties. It allows for conceptual logic so that it can be used by computer programs to make implicit knowledge actually explicit. OWL documents are known as ontologies. And OWL is part of the W3C semantic web technology stack, which includes RDF, RDFS, which RDFS is another semantic web language, and few of us actually knew how to write OWL files before this project. So not many of us actually knew how to do this work. But there were a couple people that did, And those people gave the larger group training on how to actually write OWL files. That was the second meeting that we had. We had a full day workshop on how to actually write OWL. And then once we learned that, we broke off into groups or worked on our own to create and publish OWL files based on our recommendation documents. And now all of these files are on our GitHub repository. So here's a little snippet of one of our OWL files from the custodial history OWL file. You can see that this class for accessioning is defined with subclasses, custodial event, and event classes. So here's just a little snippet that you can start to see. And it does utilize existing ontologies such as SCOS and DC terms and RDFS. And now that we have our OWL file, we can start encoding. But to do this, we need some tools. I'm going to hand the slideshow back to Melanie, and she's going to walk you through the different tools that we used, and then as well as review the outcomes and the lesson learned. Take it away, Melanie.
All right, thank you, Amber. So yes, I'll be talking a bit about the tools that we are using and the application profile work that we are currently involved in. And picking up where Amber just left off, we use Protégé and some hand coding to produce our OWL files. This is a snippet of our measurement model. ArtFrame and RAMET members were given training on how to use Protégé during our second in-person meeting. Now that we have our ontology, we need to be able to work with it. We need an editor. There are now some choices out there. For example, the BIBFRAME editor, created by the Library of Congress. This is freely available for download from the BIBFRAME website. Some participants of the LD4 group are experimenting with a CEDAR editor, coming out of the biomedical community driven by Stanford University. This tool is being used in concert with BioPortal, a searchable repository of biomedical ontologies. And based on BioPortal, there is now also BiblioPortal, which contains a large range of library-based ontologies. Since we are collaborating with the Cornell-led Rare Materials extension, we will be using the Vitrolib editor developed for this grant by Cornell. Vitrolib is based on another ontology and instance editor called Vitro. Vitrolib enables manual cataloging in RDF. The following 3 screenshots are designed to give you an idea of what cataloging in such an environment might look like. For example, when creating a new work description, the cataloger would select the plus next to work and then get presented with the fields pertaining to a BIBFRAME work. In this case, it's an audio work, since the first collection to be accommodated in Vitrolib was Cornell's hip-hop project. This is an example of a BIBFRAME instance. Obviously, we want to catalog art and not audio. We need the appropriate cataloging template that will present a cataloger cataloging an artwork with the right fields to fill out. In order to get there, we need to develop an application profile, which can be used to form the basis of such a template. There are many questions that an application profile needs to answer. For example, on which level of the BIBFRAME data model, work, instance, or item a property should appear. BIBFRAME and our extension ontology are designed to be flexible to work with many different object types. So the domain and range of many object properties have been left undefined on purpose. This means the ontology does not always specify where we should use a specific property. We need to do that for ourselves and for our own implementation. Also, we need to specify which properties and classes pertain to our material type, how we want them grouped, in which order, if we should limit the values to specific controlled vocabulary, and much more. The hip-hop music project used the Shapes Constraint language, or SHCL, to encode the application profile decisions and define their requirements for an audio cataloging template. This worked quite well, both for the metadata and the development side. And so the rare materials and the ArtFrame groups are both following the same path. SHCL, like OWL, is a W3C recommendation and allows for validating RDF graphs, or in our case, form building. Here is one example that would translate into a drop-down menu for agent roles or activity on the template. So you can see on the bottom, I started listing a couple of activities or roles that might apply to us. And this is a screenshot of what such a form could look like. Just imagine that the roles listed are art-related. One last tool that I want to point out. You might remember, or maybe not, that I mentioned at the very beginning of our webinar that Columbia's art properties data resides natively in a spreadsheet and gets transformed into MARC. One of our deliverables is to transform a subset of our existing data into BIBFRAME and into our new extension. We are using a tool called Karma, a data integration tool which allows you to map spreadsheet data to an ontology. Here I am in the process of mapping our measurement model to the art properties data. There are other tools that allow you to do that, such as Load Refine, but Karma has this nice visualization feature that makes it easier to recognize when you've made a mistake. For example, a class or property is suddenly hanging out by itself somewhere, not connecting to anything. It's been quite the journey to get where we are now. If you want to learn more, we have made everything available online, either on the LD4P wiki or on the ArtFrame RAMAT GitHub repository. So once you receive our slides, you will have all the links to the literature review, the use cases, the modeling recommendations, and the OWL file available so far. The SHCL files and remaining OWL files will be available shortly. For me, though, some of the most important outcomes can't be shared via GitHub. But maybe the various LD4P community extensions can be viewed as a first step to get more practitioners involved. Many of our ArtFrame group members embarked on this project thinking that they would only be involved in domain-specific advisory capacity. To be sure, their domain expertise and input into our use case development was incredibly valuable and crucial to our work. However, the collaboration extended much more deeply into sharing of work and knowledge to balance the different areas of expertise. Many of our extension group members became comfortable modeling specific areas for our ontology, learned how to use Protégé to translate that model into an OWL file, and are now knee-deep into application profiles and SHCL files. True, not everybody needs to be an expert ontologist, but I believe more practitioners in the community who have a grasp on the concepts will be needed going forward. Yes, ontology work takes a lot longer than one would think, and we could still be modeling if we wanted to. But we had to stop somewhere. Another lesson we learned is that vocabulary reuse from other ontology is not always as easy as often advertised. We are reusing some existing ontologies. For example, we are using relationships from RDA, but in many cases where we thought we could just reuse, either the semantics weren't quite what we had in mind, the status of the ontology was uncertain, or due to the constraints declared, we would have introduced entailments that we weren't quite comfortable with. Just think back about the style examples that Amber showed earlier on. During the modeling process, we really had to step back from the way we do things now. That wasn't always easy, and that's not just due to MARC. There are many instructions and content standards, such as DCRMG, that are very string-based. Sometimes we decided to model not what our cataloging code directed us to do, but for what we felt that we should be doing based on our use cases. There are a lot of open questions, but some of them we are actively working on. For example, once we have our art cataloging template, we will be testing our data. However, developing an ontology is one thing, but ongoing maintenance is another. A permanent home and proper versioning practices, just as two examples, will need to be developed. And this is the end of our presentation. Thanks again for attending, and to Alex for giving us the opportunity to talk about our work. And I think now we have some time for questions.
Thank you so much, Amber and Melanie. This has been a really interesting session, and I think a really good hands-on session. We now have time for questions, and if you've not done so, please type your questions actually into the question box. I did put a note saying type it in the chat window. That's incorrect. Put it in the question window. And I did have a question. You talked about how a lot of your people that you worked with started out as being content knowledge experts and ended up doing a lot more. I think you're saying of the technical work. What kind of training did they need, and how did you make it so that they were comfortable working kind of in the ontology world?
Well, we learned a lot of it was we just learned together, and there was a nice mix of ontologists and domain specialists, and we learned from each other because the ontologists didn't always know everything about the art background and vice versa. So there was I think everybody felt comfortable to say, I don't know how to do this, show me. And what Amber said earlier was really important was in-person meetings where we could then sit down and do some coding and really do it together.
Great.
And many of the group members, the domain experts, were also art catalogers or archivists, and so we're familiar with at least the idea of recording information, following content standards, following best practices, and so this was just taking that sort of a step further into another way of modeling information about art.
Great. What do you see as being, so I know you talked some about the future needs, but more long-term, where do you see, it looks like you've done a lot of work, at what point is it going to need to be revisited, and do y'all have a plan for that?
Well, we've already seen some impact affecting BIBFRAME itself. One of our recommendation documents has been accepted into the BIBFRAME ontology to have a new class for a session number. That's very simple. That was a really simple one.
Sure.
And so we're seeing that sort of impact as well. Melanie, can you speak to any more about that?
Yeah, of course, a lot of the domain communities, and not just in art, but in all of the LD4 project, none of them are really used to hosting or working on maintaining any ontology. Mm-hmm. And it's, the jury is out who's going to actually take that on and for how much. But we have an in-person LD4 workshop coming up. The one session is actually aimed at what would a domain community need to be able to do this kind of work going forward. So that's one. And in terms of maintaining, yes, even now that we're working on the application profile, and I expect that it's going to also come out when we start testing our data, really practically inputting data. There will be some fallout where we're going to say, oh, we should, there are things that we should revisit at some point. But, thinking back, all of our standards, are constantly changing. And I don't think it's going to be any different going forward.
I don't think so either. We did have a question. Is there BIBFRAME editor documentation available?
So there are a few things available. It's for download on the BIBFRAME website, and there's also I believe there's also a GitHub repo.
Okay. And then another question, how will you process the shackle shapes / constraints, and what engine or processor are you going to use for that?
Well, we are simply handing over our shackle files to the developer, and so I'm not that familiar with the technical processing on that end. I know semi-automated, but not 100%. But I can get back to the person who asked that question and investigate that more.
Sure.
Don't say anything that's not true.
Exactly. Those are the only two questions that have come up so far. How are you documenting your own processes going forward? Is it all on your GitHub account?
Yeah, it's mostly everything that's public is on the GitHub account. We of course have very deep Google Drive folders that are more internal documentation and sort of processing documentation. Things that we used. That we needed to kind of keep more hidden while we worked through issues, and then once things were more formalized, we put it on GitHub. And we also use Slack quite a bit for communication and sharing information that way as well. Slack was very helpful. And we maintained a listserv. Those were the ways that we really kind of maintained documentation and worked through documentation.
What do you think? What was your biggest pain point at doing this process, and that other groups who were looking for doing this for other types of materials should they most look out for?
Did you say pain point?
Pain point. Like, what was your hardest?
I'm sorry. Pinpoint. Okay.
Pain point. Like, what was the hardest piece of this?
Melanie, what do you think?
From what we've done so far, I would say knowing when to stop modeling.
Yes.
Because you can always make things better. You just have to at some point say we need to move on from here. And actually, our recommendation docs usually have a section on the bottom that lists future work.
Yeah.
There were also some times where we thought, well, maybe we can align with this ontology, but we just haven't gotten around to going down that road yet. So we're listing these things.
Okay.
Yeah, because the modeling for me was actually fun, but it was knowing when you were done, and when you maybe had to call it, even if you weren't done, just accepting it.
Are you planning to use this ontology for updating descriptions for 3,000 something works of art?
Well, as I said, my first step is to transform a subset of the 3,000 into RDF. And then we'll investigate that further, how we practically can use it. But I mean, that's my hope, but we'll see going forward.
Do you foresee a need to extend other schema for this project, such as to describe art collectors, styles, etc.?
I would leave. Melanie, do you want to say?
No, but
I would leave the names, and it was art collectors, and what was the other part?
Styles was the other.
Styles. I would leave that to controlled vocabularies and utilize it that way. But I mean, again, that's I don't see foreseeing any additional modeling for things like that. I do think we need to work out the derivative images issue eventually, but and administrative metadata needs to be handled at a much higher level than this project. Melanie, any thoughts on that?
Yeah, and also the style and so on. There are, vocabularies like AAT available, and they already have those areas very well covered.
Okay. One of the biggest divides I see, says the next person, is the gap in resources between the haves and have-not libraries, the ones that have the talent and the skills on staff to implement BIBFRAME projects in general. What can be done to get more libraries involved?
That's an interesting comment. Yeah, I completely agree that the institutions that host these projects do tend to be the institutions. But the participants in our groups came from a wide variety of institutions. From, you know, before I came to BARD, we had another BARD affiliate from the Center for Curatorial Studies, which is a small art library here on BARD campus. They were very actively involved with our group. So when you see those calls for participation, you know, don't hesitate to volunteer. We want people from all kinds of libraries, those haves and have-not libraries, to be a part of this, because for us to make this change, we have to work together.
Great. And the last question that we have time for today is, how do you plan to handle the creation of URIs?
Melanie?
Yeah, that's a good question going forward. I mean, we are coining URIs. If you are, you know, if you're transforming it to RDF, we are, as I said, we're linking out often to established control vocabularies locally. Yeah,
well, the VitroLib software itself creates URIs.
Yeah.
Correct, Melanie? Yeah.
I believe I'm a little bit.
So,
yeah.
So utilizing
one of the questions is, of course, one of the questions, of course, is you know, how permanent are those going to be, and so on. You know, that's why I'm a little hesitant. Yeah, there's coining URIs and there's coining URIs.
Right. Yeah.
Great.
It is a big question that still needs to be worked out.
Future development. I want to thank you both, Amber and Melanie, and we want to thank everyone in the audience. We're glad you could be with us today. You will soon receive a short online evaluation form. Please take a few minutes to respond to the questions. Your comments are very valuable, and they help the ALCTS Continuing Education Committee plan future events. The email will also include links to today's slides and recording, and you now have the opportunity to receive a certificate of attendance, and that information will also be in the email. Thanks to our presenters, Melanie Wacker and Amber Billey, and thanks also to the members of the Continuing Education Committee, Wanda Jaziri and Mary Aycock, and also to Jazz Lee Coley from the ALCTS office. The support they provide make it possible for us to present these webinars. ALCTS has other continuing education opportunities coming up. We have several more webinars this spring, including improving discoverability for non-Roman materials and a 3-part introduction to R for libraries. See the ALCTS website to register or find more information on these events. ALCTS also offers web courses, which are 4 to 6 weeks long, as well as 2-day email discussions. Our next e-forum will be on April 10th on the user experience and the electronic resources librarian. Check the website for information on upcoming courses and discussions. Thank you all for joining us today, and this concludes our session.